So in these mixture problems, I like to use a technique where I think about putting things into buckets. So if we read this problem here, it says a scientist has two solutions. So first off, I know that basically I'm going to be mixing two solutions. So the first thing I do is I draw two buckets. So I've got solution A and I've got solution B. And solution A and B together are going to make this new solution that we're making. Okay. Then it says that she knows that solution A is 60% salt and solution B is 85% salt. So I'm going to put the percentage in here. We're going to write the percentages as a decimal. So 60% is 0.60 and the 85% would be 0.85. And then it says she wants to obtain 170 ounces of a mixture that's 80% salt. So I'm going to keep the 80%. I keep all of the percentages down in the bottom of like my beakers. I kind of think of them. And in the top of the beaker, I put the amounts. So down here in the bottom line, I'm putting the percent. And up here in the top part of the beaker, I'm going to put the amount. And so it says that she needs 170 ounces. And then the word problem doesn't say anything at all about how much of solution A and how much of solution B she has. So we're just going to give them variables. So we're going to make X plus, and then we'll make B be Y because they're different. I don't know how they're related. The only thing I know is that when they come together, it makes 170 ounces. Okay, then you're always going to get two equations. So one equation is going to be what I call the amount equation. And so that's always going to be this top row. As long as you've put all the amounts on the top row, then that's going to give you that equation. So in our case, the amount equation is going to be X plus Y equals 170. And then the other equation is what I call the concentration equation. So the concentration includes the amounts and the percentages. And so what we're actually going to do is we're going to take each of these beakers and we're going to multiply the two things together. So if I multiply these two things together, in each of the beakers, I'm going to have 0.60x, 0.85y, and 170 times 0.80. And so this second part down here, this is going to be my concentration equation. So it's going to be 0.60x plus 0.85y equals 170 times 0.80. And so we have to figure out what 170 times 0.8 is. And if you do that, this part here is 136. So I now have two equations to work with. I have x plus y equals 170, and I have 0.60x plus 0.85y equals 136. And so what I'm going to do is I'm going to take this first equation here, and I'm going to solve it for x or y. It doesn't matter. I'll pick x. So if I solve it for x, I need to subtract y from both sides. So x is going to end up being 170 minus y. And then I'm going to take it and plug it in for x in this second equation. So this is going to become now 0.60. And then instead of this x here, I'm going to put all this stuff here, the 170 minus y. So 0.60 times 170 minus y plus 0.85y equals 136. I need to distribute the 0.60, so it has to go to both of those things inside the parentheses. So 0.60 times 170 minus 0.60y plus 0.85y equals 136. So 170 times 0.6 is 102. If you notice, the minus 0.60y and the plus 0.85y, they both have y's in them. And so therefore they're like terms, so I can put them together. So that's going to leave me with plus 0.25y equals 136. And I'm just trying to solve for y, so I'm going to subtract 102 from both sides. So we have 0.25y equals 34. And I'm going to divide both sides by 0.25. So y is going to be 34 divided by 0.25. Punch that into my calculator. Is 136. And then now, and it's just coincidence that you had 136 up there, and now you also have 136. To find x, right? So remember, from here, x is 170 minus y. So x is going to be 170 minus 136. And if I do that, that's 34. So what that means is, remember, x went with the 60%. So we need 34 ounces of 60%. And the y, the 136, that went with the 85%. So 136 ounces of 85%. And so we're going to do every single mixture problem in this same fashion. So I have a couple more. I think I have like 3 more of them here. So the next one, it's similar, right? It's not chemicals. This time it's vinegar. But it says a chef is going to mix 2 brands of Italian dressing. The first brand, right, is 5% vinegar, so 0.05, right? Remember, I have to write it as a decimal. The second brand is 15% vinegar, so 0.15. And the chef wants to make 290 milliliters of a 14% vinegar, right? So just to remind ourselves, the top line is the amount, the bottom line is the percents. And again, just like in the last problem, I don't know, they didn't give me any information about the first or the second type of vinegar. So we'll just call this first one X and the second one Y. And just like before, this first top line gives you one equation. That's the amount equation. Right? So if you think about it, if I'm mixing things, the amounts have to work out correctly. And then the other part that has to work out correctly is that concentration. And remember, to get the concentration, we're going to multiply everything in the beakers together. So 0.05x, 0.15y, 0.14 times 290. And so that's going to be that concentration. So 0.05x plus 0.15y equals 0.14 times 290. And if you multiply 0.14 times 290, you end up with 40.6. And so again, now I have 2 equations. So x plus y equals 290. My second equation is 0.05x plus 0.15y equals that 40.6. And so what I'm going to do here, just like I did before, I'm going to solve that first equation for x. So x is going to be 290 minus y. And then I'm going to plug that into the second equation. So 0.05 times 290 minus y plus 0.15y equals 40.6. Just like we did before, we're going to distribute that 0.05. So this is going to become 0.05 times 290 minus 0.05y plus 0.15y equals 40.6. So 0.05 times 1 times 290 is 14.5. So 14.5, again, the minus 0.05y and the plus 0.15y are like terms. So this is going to be plus 0.10y equals 40.6. I'm trying to solve for y, so I'm going to subtract 14.5 from each side. So we're going to get 0.10y equals, so if we take 40.6 minus 14.5, we end up with 26.1. And then we divide both sides by 0.10. And y is going to be, so 26.1 divided by 0.10 is 261. And then again, we have to find x. So if y is equal to 261 and x is equal to 290 minus y, that means x is going to be 290 minus 261, which should be 29. I think I did that right. Did that in my head, and I should really always use a calculator because, yeah, 29. Okay, and then again, you want to write your answer by saying what we found. So we're going to use 261 milliliters of, so the y went with the 15%, and 29 milliliters of the 5%. And that's the part that is the final answer. That's what we're looking for. And Alex will generally ask you, how much of this percentage should you use and how much of this percentage should you use. So again, I really like this bucket approach. We're going to keep using it on my next two problems as well. But just so that you get an idea of how to do it. So, a chemical company mixes pure water. Okay, so my first bucket is going to be pure water with their premium antifreeze solution to create an inexpensive antifreeze mixture. Okay, so we're going to mix one with another one. The premium antifreeze, right, so that's what's in this bucket, the premium. The premium antifreeze contains 80%. Okay, so 0.80. The company wants to make 320 gallons that contains 55%, so 0.55. Okay, and we got to figure out how much water and how much premium. But if you notice, unlike the last two problems, there's something missing down here. That percent is missing down here. And the thing is that it's not really missing. So if you look at these, the 80% and the 55% is talking about how much antifreeze. And if you think about, the key here is the word pure. So the pure water, when we say pure water, what we're saying is that it has no antifreeze in it. So the percentage of antifreeze is actually 0 here. And then again, I don't know how much water, and I don't know how much of the premium, so we're going to make that a y. Just like before, we're going to take that first line here. That's my amount equation. And so it's going to be x plus y equals 320. And then we're going to multiply the things together. So 0x plus 0.80y equals 320 times 0.55. So my concentration equation is going to be 0x plus 0.80y equals 320 times 0.55. Now, 0x, right? 0x, that's just 0. And then 320 times 0.55, this part here is 176. Whoops. Kind of just hit the pen there. So my two equations here are going to be x plus y equals 320, and 0.80y equals 176. So this is a little bit easier of a problem because if you notice in the second equation here, all I have is a y. So all I'm going to do is take this and I'm going to divide both sides by that 0.80 to figure out what y is. So y is going to be 176 divided by 0.80 is 220. And then we're going to plug that back into, we know that x plus y equals 320. So x plus 220 equals 320. So I'm going to subtract 220 from both sides. So x is going to be equal to 100. So we need 100 gallons of pure water. And we need 220 gallons of the 80%. So this one's a little different. The thing that's different about it, again, is this 0, okay? But if you set it up in these buckets, the way that I do these problems, you're not going to go wrong. So I think I have one more on here. Yeah. So a chef plans to mix 100% vinegar. Okay, so 100% as a decimal. So again, remember, 100%, the way that we go from a percent to a decimal, right? Like 12%, the reason 12% is equal to 0.12 is because you're taking the decimal point that's right here at the end and you're moving it 2 slots to the left. So if I take this decimal point and I move it 2 slots, my decimal is actually 1 point. You could think of it as 1.00. Plus, my second one is the Italian dressing contains 12% vinegar, so 0.12. And the chef is trying to make 320 milliliters of a mixture that contains 23% vinegar, so 0.23. And again, I don't know how much in this first one. I don't know how much in the second one, so I'm just going to call them x and y. And here's my first equation, right? That amount equation is going to be x plus y equals 320. And then that second equation we're going to get by multiplying. So this right here is just 1, right? So it's going to be 1x. This is 0.12y. And this is 0.23 times 320. So that concentration equation is going to be 1x plus 0.12y equals 0.23 times 320. And 0.23 times 320 is 73.6. So my two equations are x plus y equals 320. And then x, I don't have to write the 1 in front of the x, right? Because 1 times x is just 1. So x plus 0.12y equals 73.6. And so if we take that first equation and we solve it for x is going to be 320 minus y. And if I plug that into my second equation, I get 320 minus y plus 0.12y equals 73.6. And the reason that's the case is because, remember, this part here, this is x, right? So I just replaced x with what it was. And I didn't put parentheses around it this time because there wasn't a number in front of the x. Like my other examples. But you could definitely, if you wanted to, you could put parentheses around it. That's okay. And then just say, okay, in my next line, okay, so 320 minus y plus 0.12y equals 73.6. So remember, there's a negative 1 here in front of that y. So negative 1 plus 0.12 to add the like terms together is going to give me negative 0.88. So I have 320 minus 0.88y equals 73.6. If I subtract 320 from both sides, I've got 0.88y equals, so 73.6 minus 320 is, oh, my calculator just died on me, is negative, oops, this should be negative 0.88, right? Forgot my negative there. So this is negative 246.4. And I'm just going to move up here, so because I'm running out of the page. So negative 0.88y, I'm just recopying what I had, is negative 246.4. So I'm going to divide both sides by negative 0.88. And so y is going to be 280. And then remember, x is equal to 320 minus y. So it's going to be 320 minus 280. And that's 40. So we need x, we need 40 milliliters of the 100%, because x went with the 100%. And we need 280 milliliters of the 12%. And so again, if you keep setting up these buckets, then I think these problems actually aren't too bad. You definitely want a calculator to do them because this is ugly math to try to do in your head without a calculator. But I would definitely, on all the problems, try to do the buckets. I tried to do problems similar to the ones that you guys will have to do so that this can help you out.